Hi, my name is Firdaus,
Hi, I am Adam.
and today we'll be reviewing a video on the topic of
Will quantum computers break encryption?
The security of the internet depends on encryption. It allows your device and a faraway server to send private messages to each other, like your emails, passwords, and pictures of cats, without anyone eavesdropping.
But quantum computers are already here.
Yeah, I know. There are quantum computers on the market, but these are not the scary ones. They use quantum annealing to solve certain optimization problems.
a quantum computer is the computer that utilizes quantum mechanics to perform operations unlike a classical computer. Quantum annealing specializes a quantum computer to complete specific tasks such as solving certain problems, such as optimizing problems and sampling problems, which are mostly used in towards some type of scientific research. Basically, quantum annealing does not yet have much to do with quantum security, which is mentioned in the video, so good job on that.
Are we doomed? Maybe.
Overall, I would say quantum computers are regarded positively, but here and there is an article that criticizes quantum computers, claiming that modern systems of finance, communication, transportation, etc. will break since quantum computers will easily break the encryption. Because everything today is managed digitally, like emails, bank accounts, and so on, this raises many concerns. This theoretically includes cryptocurrency like Bitcoin, even though they're not there yet.
Bitcoin is theoretically vulnerable to being cracked by quantum computers, but calculations show that the quantum computer that exists today must be almost 1,000,000 times larger to be able to do that. In order to break the algorithm that sources Bitcoin, which would put the cryptocurrency at risk from hackers, the Bitcoin network is kept secure by computers known as miners that uses a cryptographic algorithm called SHA-256, which was created by the US National Security Agency. Breaking this code is essentially impossible for ordinary computers, but quantum computers, which can exploit the properties of quantum physics to speed up some calculation, could theoretically crack this open.
So what if you scramble your messages? Write them in a secret code. Okay, then how are you and the server supposed to unscramble each other's messages? If you tell each other how to unscramble them, then the eavesdropper knows how to unscramble them too, and all of this is pointless.
The two words that were just used, scrambling and encryption, they were not really explained properly, because that is scrambled using a control word, but then it is protected using encryption.
Without access to each other's key, how are you supposed to unscramble each other's messages? Here's how we get around this problem today. Say that you want...
I suppose it is kind of awkward that the 3 letters appear on the screen. The speaker does not even acknowledge them very clearly. I suppose when something like that appears, I would like at least a little bit of an explanation. Like an RSA algorithm involves 4 steps: key generation, key distribution, encryption, and decryption. Or what we have been describing here all along is called RSA.
Unfortunately, the particular one-way function that most of the internet uses can be broken by quantum computers. They make it easy to get the private key, but only because there happens to be an algorithm to do it that performs very well when it's run on a quantum computer.
Shor's algorithm is a quantum computer algorithm for finding the prime factors of an integer. The reason why it could break the encryption so well is because RSA is based on the assumption that factoring large integers is computationally intractable. The explanation of this part was sort of omitted, but I think it is okay. This really is some extra information, and while it was not fully explained, it is nice to at least have something to research. He could have moved on without mentioning Shor's algorithm, and it would have been fine, but it is good that it was at least mentioned.
The server generates a random string of 1s and 0s. We are going to use these 1s and 0s to make a key. The server encodes these bits into qubits by randomly choosing a vertical or horizontal orientation.
When I compare it to the classical encryption, the first difference I spot is that instead of 2 options, which using regular bits would be just 1s and 0s, there are now 4 different options, which are vertical and horizontal qubits. So this alone makes the whole thing more complicated and probably harder to decrypt. Yet that is still not the point. The point is that measuring the qubit actually influences the result. Now, where has this quantum mechanics principle been described before? Well, in the Schrodinger's cat experiment, of course, where a cat is placed in a box with a 50-50% chance of being found dead or alive. before the box is opened. So I think this really relates to this concept, except here you have an either vertical or horizontal qubit that's either 1 or 0. I think it is very well described, although I definitely think it is a huge knowledge and understanding jump. So maybe more explanation of quantum mechanics within this video might help. Fun fact, a qubit can actually hold up to 2 bits of information.
Each time, you have a 50-50 chance of guessing right, since there are only 2 possible orientations and you have to pick one of them.
The narrator does not really mention quantum superposition. I suppose it's a big word in this video, but I think it is an important word to be said, because it is what he is trying to describe here. Because quantum mechanics allows the qubit to be in coherent superposition of both states, which essentially means that multiple measurements made on qubits in identical states will not always give the same result, because the qubit generally is actually neither 1 or 0.
Too bad they would need to break the laws of physics to do that. A principle of quantum mechanics, known as the no-cloning theorem, tells us that you can't make copies of qubits if you don't already know what they are.
The no-cloning theorem is a result of quantum mechanics which forbids the creation of identical copies of an arbitrary unknown quantum state. It was stated by Wouter, Zurich, and Diggs in 1982 and had profound implications in quantum computing and related fields.
Unless you're astronomically unlucky. But to better your odds, you use more qubits, so small mistakes from the eavesdropper are more likely to be noticed.
So I believe the idea here is that the qubits the individual receives are meant to match 50% of the qubits the server sent out. If the qubits are measured beforehand by an eavesdropper, the number of qubits that are received by the individual will no longer match 50% of the qubits that were sent by the server. If this could be more clearly stated, considering the qubit is in superposition, a measurement of a qubit disturbs the superposition state it was sent by the server, while a measurement of a regular bit will not disturb its state. I suppose one could even look at the many worlds interpretation, where the observer's state and cat state are somehow entangled or linked so that they correspond with each other. I do really like the graphics. Visuals like these really simplify concepts that would otherwise be really complicated.
You can use the mismatches to check for an eavesdropper. You know there was an eavesdropper if something called Bell's inequality was satisfied. If Bell's inequality is not satisfied, it means that there was no eavesdropping.
If you compare this part to the rest of the video, I really think this is probably one of the weakest parts, if not the weakest. The amount of explanation in this video during other parts is pretty good, but here you don't really get what the guy is talking about. He makes some comparisons between the qubits, but doesn't really comment on it. Then he brings up Bell's inequality, but he doesn't really specify what he means by that. I had to watch an entire other video to at least get an idea what Bell's inequality is. To summarize it in a few words, quantum theory predicts the probabilities of this whole exchange. Bell's inequality predicts different probabilities. So if the quantum mechanics of this exchange are somehow tampered with, Bell's inequality will be satisfied and there is an eavesdropper.
Every new discovery comes with opportunity and costs. We can't complain when the eavesdroppers are just using superior tech to our own. The threat is real, but people believe in advancing science and technology.
Overall, the video is very well done. This video can help anyone with absolutely no knowledge of encryption to understand the idea of how our data is being transferred over the internet and how encryption works. The visual aid and the animation helps understanding encryption and decryption. The scope of the video is perfect range in terms of having enough detail to explain the concept of encryption and quantum computers. The video also provides an idea to different usage of quantum computers besides breaking encryption and the dark side of quantum computers.
If you only knew the power of the dark side.
Quantum computers will open a pathway to new possibilities such as database performance, more accurate simulation of quantum mechanics, which would also help improve research such as in the field of medicine, to find cure for unknown diseases. And therefore, every new discovery comes with the cost but also opportunity. The threat of eavesdroppers using quantum computers for their benefit is real, but we must believe in the advancement of science technology because the potential of using it to improve our lives and improve the way we live. Therefore, I gave this video a solid 9 out of 10.
This video has a clear focus, and even though it does not go into much explanation of a few topics, I still prefer them to be mentioned at least, rather than completely ignored. I just think that especially with Bell's inequality, it's not very well explained, and then I think the cartoon does not even paint a good picture of the idea. But other than that, this video is very good at providing a basic explanation of quantum encryption. It's especially good with all the visuals. I would say it's an 8 out of 10. This is a fantastic video, but I think there are videos out there that maybe explain quantum cryptography specifically slightly better to a beginner. Of course, I suppose you have to keep in mind this video is obviously trying to be only 15 minutes long. I would also like to add that quantum computers help develop cleaner technology, for example, developing quantum battery technology or material discovery. I believe that the idea is that both quantum and traditional computers will work together instead of one replacing the other.